Hello, and thank you for tuning in to the Esri box set presentation for the ArcGIS Runtimes. My name is Steve Lowery and I work for Professional Services here at Esri UK. This video is designed for people that are considering developing their first app and have little or no experience of the runtimes. So the agenda is: what are the runtime APIs? How are they developed? How can I get started? What skills are required? I'm then going to show you developers.arcgis.com, which will provide you with the runtime installers, resources such as base mapping, and facilities to manage your online content. I'm then going to explain how you can author some data, or in other words, putting some maps in your app. I'm then going to show you some of the sample options available to you. And then I'm briefly going to touch on developing multi-platform apps with AppStudio. So what are the runtime APIs? The core of runtime was written in C++ for performance. Most of the methods within the core are written asynchronously. The runtime was then compiled for x86, x64, ARM, and ARM64, targeting 6 operating systems: Android, iOS, Windows, Linux, macOS, and the Universal Windows platform. Graphics subsystems are used extensively, especially on 3D analysis and rendering, to increase performance. Core is compiled to target the devices that it can be deployed to. APIs include .NET, iOS, Android, Java, and Qt. The best way to regard the APIs is an interface onto this raw C++ runtime code developed for performance. So often the API wraps up a series of C++ routines into one line of code. It abstracts the functionality of core into a developer-friendly interface for you. Why would you want to build a native application? Well, native apps have superior performance compared to browser apps. Asynchronous API methods make the map and other rendering very responsive. Native apps can work offline, and also the data can be taken offline, which is often not possible in browser apps. Full access to the target device's capability, i.e. GPS location, camera, fingerprint security, can be accessed. You also gain access to the peripherals attached to your device via SDKs. Also, the debugging is a better experience and productive. You get the use of the IDE's breakpoints, object inspectors, and so on. Below are a couple of images of the OpenGL libraries being used to perform some quite complex 3D analysis, and we'll take a look at some samples that leverage that later. So what skills are required? It depends on your development approach. Code ninjas may develop from the ground up, opening up a blank project, adding the runtime libraries to them, and cracking on with code. Developers with a little knowledge can cross-skill using samples. There are hundreds of copy-paste friendly samples for most tasks. There are also complete projects which may achieve close to what you need. You could maybe tweak an open source project to get it to do what you require. AppStudio, again, which is touched on later, wraps these runtimes up into a UI with little coding required. So, installing the runtime of your choice. For API downloads and resources, we have to visit developers.arcgis.com. This is your one-stop shop for managing your content, using base maps, and of course, installers for the runtime APIs. You'll need to register to gain access to resources, and the good news is registration is free. Once registered, you will be able to download an API, view sample data, access base maps, etc. If you have an idea for an app, you can visit success stories detailing sector-specific applications to see what others have achieved. Applications can be developed free of charge. When you register, you get 50 free credits to access online maps and Esri services such as routing and geocoding. Let's take a quick tour of developers.arcgis.com. Signing up is very easy and non-invasive. We just need a first name, a last name, an email address, agree to the terms and conditions, then hit send confirmation email. Once you respond to that email, everything will be set up for you. So I'm going to log in as myself, and you can take a look at my landing page. So this is my landing page or dashboard. As you can see, I have 250 credits, which has been set up for me. When you set up your account and register with ArcGIS Online, sign up, you'll get 50 credits. I get 250 because I'm a member of Esri UK, as I say, but 50 should last you through the month for regular development purposes. And at the end of that month, 50 credits get renewed. So this is my dashboard. I can do several things here. I can manage my content. So when you set up your account, you get an area of ArcGIS Online specific to you, where you can store your own base maps, web maps, feature services, etc. So here are mine here. These can be accessed via your Runtime API. So you've got your own private area of ArcGIS Online set up for you once you register. Another thing you can do is download the SDKs. So I've currently got the .NET Runtime SDK installed and the Android SDK installed. So when you get a moment, please take time to download the API of your choice. Another great web page is Getting Started, which most of you probably will be getting started. So the first thing to do might be to have a look at what is ArcGIS. A lot of terminology is mentioned throughout the documentation and the online resources to do with base maps, web maps, feature layers, and so on. So this will give you a good idea of our WebGIS model. We've also got documentation, which is a list of methods available within each API, which you can reference here. I tend to use something called Sample Viewer. So if I download one or show you how to download one specifically for your API, this samples view is a very neat tool and I use it pretty much all the time. It enables you to view a live demo of the sample, but also the associated code with it. You can also search based on functionality. So if you wanted to learn how to query a feature layer, you type in query a feature layer and it gives you all the samples and also a live demo of that code running. So I do use this quite extensively. Okay, you've learned how to find your API and install it. The next thing you may want to consider is your map data. So I'd like to talk about authoring data or putting some maps in your app. We may need some base mapping. Your online account will give you access to a wide range of base maps. If you work completely offline, you can access local data side-loaded onto your device. Base maps act as your canvas. You will probably place your own operational data onto a base map, i.e. local schools, fire stations, etc. Data which is specific to your organisation. Your operational data will require symbolising. We can discuss some various options. You have an option of authoring data via the geoinformation model. So the geoinformation model is the model for WebGIS. ArcGIS runtimes are designed to work with WebGIS. Essentially, this means ArcGIS runtimes are designed to work with your online data in your content. Referencing data from web maps provides one authoritative source for the data. Maps can be updated on the fly with no need to recompile the runtime client. The data can also be kept up to date. Security models developed in WebGIS are cascaded down to the runtime client. So if you use AGOL to restrict the access to certain layers within a web map, the user requires permission to access each layer. If there is no permission, they have no visibility of the layer. Complex visualization models can be developed in 3D scenes and 2D web maps. Complex symbols assigned to layers in the web map appear exactly the same way in runtime, which we'll see later. There's also an option to completely build your content up from raw data. Raw data could include local sideloaded, data sideloaded onto your device. This method is far more flexible. It provides more data type options, but the rendering of symbols has to be undertaken in code, and this can be quite time consuming. Data is loaded layer by layer, so this is less flexible than WebGIS. If a new layer is introduced, coding and a recompile will be required. Working with offline data. Offline data is essentially a process where you request data from your ArcGIS Online account. The data is downloaded onto your device. The user often goes off into the field with a poor network connection, edits the data from data stored on the device, and when a network connection is available or at the end of the shift, the data is then synced back to ArcGIS Online. Runtimes provide methodology for taking your data offline and referencing it from device storage. Offline editing is not supported in the browser APIs with JavaScript. ArcGIS Enterprise settings for your data will require configuring for users to download. This is all done using the settings menu in ArcGIS Online. Workflows can be configured online. Data can be loaded onto the device in a pre-planned mode. Each user has a predefined work area. The data is pre-staged and can be quickly updated each day. So in ArcGIS Online, you define a predefined area for each user. Data can be loaded on demand. The user selects data for a defined area. Using this can be quite processor intensive as the data isn't staged because there's no idea of what area the user will select. So this has to be used in caution because it is very processor intensive. Synchronizing your data back to ArcGIS Online is one line of code. And there's a really good video produced by Esri Inc. I've included the link in this slide. So if there's types of data using WebGIS layers and services. So within the ArcGIS Runtime client, we can view feature layers, raster layers, map image layers, scene layers, which are 3D layers, vector tiles, and OGC services. And please feel free to refresh yourself on this terminology using the Getting Started What is ArcGIS section we viewed later. Types of data from local storage, feature layers with vector data access, mobile geodatabases using SQLite, geopackages, shapefiles. These have read and write access. We can also access raster layers via mosaic data sets. There are 10 plus image data formats supported. We can also view KML layers. We support OGC KML 2.2 with extensions, mobile map packages, scene packages, and vector tile packages. Working with 3D data. Using the local graphics processing capabilities of the device, high performance is attained. You can use 2D layers in 3D scenes. However, some layers are specific to 3D. These include terrain, 3D features, models, and meshes. There are many 3D analysis capabilities and some interactive tools. For example, viewshed. If I am at a point at a certain height, what areas around me do I have line of sight on? And alternatively, you can do line of sight just between 2 points. You can also undertake things like floodplain analysis using 3D analysis routines. Let's do a quick demo. What I intend to do is create a WPF.NET application from the ArcGIS Runtime template in Studio, customize the runtime generated template, explore some pre-authored data in Enterprise, and take a look at some base mapping. Examine how Runtime seamlessly renders this pre-authored data. Okay, we're going to create our first .NET Runtime project using the .NET WPF Runtime. I've just opened up Visual Studio and gone into Create Project. You can see here that when I've installed the .NET Runtime, it's also added a template for me to Visual Studio. So I can go right ahead and create WPF.NET Runtime app. Give it a meaningful name. Hit Create. And here we have code. What the template's actually given us is some skeletal framework and some templated code. We can see the code behind and the map view model. So the template is giving us an MVVM structured project, and here's the code. You can see we've created a map and we've added a base map to it. Very, very simple, very, very concise. But let's go ahead and run this basic project. So the template has given us a default map, which we can pan and zoom around. So I've taken this skeletal template and I've customized it slightly, adding a couple of user controls to the left-hand stack panel, which I've added some functionality to change the base map and add our own web map. I can show you that now. Run this application. So the idea is that we can change our own base map. So this is giving the user control to select a base map, and this is loading our own web map from my content. And you can do similar things using your content, author maps, and then add them to your runtime application. Let's take a look at my content and see the web map that I've authored. So this is the web map in my content. You can see I've added a couple of layers, crime hotspots, and some box set point locations. The main point to take away here is that there are some custom symbols defined or authored in my web map. I could similarly have authored some security and restricted layers to certain users. So let's take a look at that in the Runtime app. So let's try changing the base map to imagery, get an imagery layer. Most of these layers are available to you, part of your online content. OpenStreetMap is quite a nice base map to use. So let's zoom in around the UK and add our own web map. Notice how the symbology we authored in our WebGIS is also reflected in Runtime. The implication being that you don't need to code any rendering routines yourself. It's all done via the authoring in WebGIS. So code for this is not particularly large. This is where we load our own base map using the ID that you can derive from your content. And this is where we change the base map. So you can see that these are basically 3 lines of code running off event handlers to change the base map and add your own web map. And this is a good example of the API extracting the complexity of .NET Core and all the heavy lifting into just 2 or 3 lines of code, saving you huge amounts of time. Okay, let's take a look at what we've achieved so far. We've created a WPF application and added some content via WebGIS. If you decided to download one of the other 6 APIs, the principle will remain the same. All of the runtimes work the same way. They all use the same C++ runtime core, which implies that all APIs have the same performance. The principle of adding a base map, loading some authored content, will remain the same across APIs. It's just the UI controls and the associated languages that differ. What next? Well, let's take a look at some more interesting components of runtime. Spatial analysis. It may be you just need to create a map viewer application with some simple map queries. The real power of runtime is the spatial analysis capability. The statistical and spatial analysis capabilities are vast, to name but a few. Proximity analysis, what features meet certain criteria, i.e. fall within an area and satisfy an attribute query. You can use geocoding. Network analysis, you can find the shortest route. You can also find the shortest route after you've added some blocks and shut roads off. And you can find service areas. Where's my closest facility to my location? There's also some really exciting 3D scenes and their associated analytical routines. The best way to explore runtime capabilities is through the sample viewer. So if you can remember, I recommended downloading the appropriate sample viewer for the API you may have chosen to download. I'm going to be looking at the .NET viewer. So the sample viewer can be downloaded from arcgis.developers.com, as you saw when we took a tour of developers.com. There are hundreds of samples available with the viewer and on GitHub. You can view live samples and find one that's close to what you want to achieve. You can also switch the view to examine the code. Code is copy-paste friendly. There are similar code samples for other APIs. We'll take a look at the .NET version. Okay, so this is the ArcGIS Runtime SDK for .NET samples. The index on the left is grouped by functionality. So if you want to look at analysis samples, you can click on analysis, take a look at all the samples that have been provided for you. I'm going to start by trying to find out how I add a feature layer to a geo package. So I'll search search bar for geo package. Oh, here it is here, feature layer geo package. So there's not an awful lot going on, but if I wanted to find out quickly how I access feature layers and geo packages, I could search in the bar. So here's the source code. It's fairly concise, calling an async routine, and I can copy and paste this into any app that I'm currently developing. Probably a good idea just to peruse the code and get some idea of the functionality and what's going on. But I just tend to use this so much of the time to save effort. I look at some rendering samples. Raster Hillshade renderer. This is the code. And if I apply the renderer, this is an example of rendering yourself in code as opposed to letting ArcGIS Online author the data for you. Another useful function is convex hull. I don't know if many people have used this before. Convex hull basically gives you the extremity of a point collection. So if you had a series of incidents within a particular area and wanted to quantify that with a polygon, you create a boundary out of a point data set. So if I go ahead and add some points and create convex hull, that's created an extremity of those point features for us. If you want to use offline editing, there's a sample for creating a geodatabase, downloading the data from ArcGIS, and then resyncing the data. As I said before, resyncing data is one line of code. We have a look at some spatial operations, which I touched on in the last slides. Spatial operations, there we are. This gives us some idea of what the capabilities are in terms of spatial analysis. So we can do a difference. What's the difference between those two polygon areas? What's the intersection? What's the symmetric difference? And what's the union? There's also facility to add data directly to ArcGIS Online. So this isn't taking data offline and then resyncing back. This is adding features directly to your feature layer in your content. So let's take a look at that if I can find it. Here it is. So what we're going to do is click, gives us a message saying it's successfully created. You'll probably take that out in a production application. So here we are adding features. The one thing we could do is I've taken a look at this source code, not too onerous, and I've changed the code slightly so that it now points at some of our own content. So here we have the application we developed earlier. And here we have that application you just saw in the sample viewer, but modified slightly to point to our data. So let's load that web map. So here we have the two apps side by side. This is our customized map viewer, and this is the code from the sample viewer that adds features directly to our feature layer online. So let's go ahead and add a few. Zoom to Paris. So if I add a couple of features here, this is on a refresh, as you can see it appear over here. So the scenario might be that you have someone out in the field with a permanent connection adding features, and back at base you can see those features as they're added. Takes a while to refresh. There we are. So by all means use the sample viewer if you can. It's a nice tool, speeds up development no end. Okay, I'd like to finish off by introducing you to AppStudio. Some people may have limited time to develop their apps. Another option is to use AppStudio. AppStudio is cute and all of the runtimes wrapped into one, with 4 templates and around 80 or so samples to base your application on. There's a very intuitive interface, and applications can be developed simply using the UI and configuration settings alone. Survey 123 was written using this application. So here's the IDE layout. Here you can see that I can base my application on a template, or alternatively, I can go to one of the samples and view those. This is an example of the QML markup language. You can access this via hitting this icon here. You can also use an editor of your choice, such as Microsoft Visual Studio Code. Here you can see an example of what you get when you edit QML. And you can see here that it's importing the runtime for you, and you can call runtime routines directly from QML required. Now comes the really good part. After you've uploaded your up-to-A goal, you can build it. So you select the build button. You have two options to make your project, one being in the cloud and one a local make. So let's look at the option cloud build. You can see here that I can target multiple devices, analyze the build, and then go ahead and build it. So a developer edition is required to perform a cloud build. You can build for multiple targets, all done for you in the Esri cloud. You get an email when the builds are complete. If your organization uses multiple OS versions on different devices, this is invaluable. Coding is only required once, so that same code can be used to produce applications for multiple devices. For a comprehensive introduction, Esri Inc. have a really good video on YouTube if you're interested in learning a little more, and I've included the link at the end of this slide. And finally, thanks for watching this short introduction to the ArcGIS Runtimes.